In today's video, I'm going to show you real-world examples of how we can optimize your Postgres database for big data. So I'm talking multi-gigabytes tables, which I do for my clients at sunmoon.co, where I do consulting. And then after that, I'm going to show you what are my different techniques that I use inside. And as you can see, we cut our execution time by about 11x the initial execution time. Hey guys, just before the video starts, I just want to tune in and say that we're gonna be hosting a live Q&A session on basically fully self-hosted Next.js, Supabase, and Coolify app, like I was showing in the previous videos of setup. We're gonna be doing it on November 28th at 6 p.m. Eastern. So tune in to not miss the live, where you can ask all your questions, and I'm gonna be answering those live with you guys. And I hope you enjoy this video. So let's get right into it. So first things first, just to set the table, we're gonna have two tables. So as you can see, those tables are pretty much the same sizes. So they all have the same number of rows. One is 18 gigs and the other is 22 gigs. The main difference is one is partitioned and the other is a plain old SQL table from Postgres. So you can see the schema for public.books. So we have all those fields right here, an index that is used on basically the ID column of public books. And we also have in books parted, which is the partition table. The single difference we have is we have a unique index based on the language, the IS and the two ISBNs, which is a bit overkill. And we also have an index on the ID, which is the same thing as the other one. So right now we're going to compare what's the difference in speed for partition table and indexes. So what are both of them? So a partition table is basically a table which you have one big table and you choose a way to basically split it into smaller chunks so that when you go search to the parent table, you don't search the whole table for a certain value. So in my case, I'm hosting books for the MyBookQuest search algorithm to make it better. And my goal is basically to split the books by languages. So you have basically a column language right here, which is not null. So it's always going to be a sign of value. And basically what happens is if the book is in English, it's going to be split into a separate table under the books parted table. So you can see our partitions here in dbeaver. So as you can see right now, we have all the languages that are split up in another single chunk table. So we have all the values that are basically by language. So it's ISO specific language, so that's a global ID. And basically we subset the books part of the table with an underscore of the language. So you can see the row count estimate for everyone. And yeah, some have more, some have less, obviously. As you can see, we have some that have 2 or 3 names, but we don't care. We gonna get some gains still after that. So now that you know the difference, right now we're just gonna go into the test I made. So for each combination, what I did is I went and selected a value for the language Spanish, which is the third or fourth most present language in those tables. So there's probably 3 or 4 gigs of Spanish rows in there, which is about a few million rows. And we're gonna search for a specific ISBN that is basically in Spanish. So we got 2 arguments in our where query. And what we're gonna do is first off test it without indexes and no partitions. So I'm gonna explain the meaning of that right after. And we're gonna do it without indexes, with partitions, with indexes, no partitions, and with indexes, with partitions. So you can really see what the power is of partitions and indexes. And is it good when you're doing both of them? That really depends on your use case, and that's why you need expert advice on that. So I ran those for you in those results, and what I did is I used a tool called um, explain dpaz, which is one of my favorite tools to show the explain analyze logs, which is basically it shows the results of your query and an estimation of the time it's going to take, what the PostgreSQL engine is going to do. Um, and this is really where you can optimize your queries by looking at what operations take the most time. So that's what I'm going to show you. So the first one is without indexes, without partitions. So as you can see, it's pretty straightforward. What we have is a basic one operation. So the first one is basically a gather, which a gather is basically to launch different workers to do a subsequent job. So as you can see, we have on the level 2, we have a 707 millisecond job. And basically we're just doing a parallel sequential scan. And what a sequential scan is basically it goes to every row and it tries to find the value. So let's say you have ISBN 13. What it will do is basically go on each ISBN 13 and look at the value till it matches this row. And as you can see, from those filters, we remove 3 million rows, and we have about 30 million rows in the table as a whole. So we only filtered 3.6 million, which is not that much. And after that, it's just a sequential scan to find the right data, right? And as you can see, the cost is really where we're showing the biggest loss in performance that we're getting. So we're pretty much scanning 25.88 million, 880 million rows just to find those two values, which is extremely inefficient and extremely long in any case. So then I want to show you the first thing. So the first thing I do when I work with clients with big databases, what we do is we start using indexes. So indexes are basically a way to tell PostgreSQL where are data basically situated in your table. So it allows them to, when you're doing a scan, the engine basically knows pre-scan where each row is. So that allows for way faster table execution times, because it basically reduces the sequential scan that is required when you don't have any indexes. So see the difference here. We're at 861 milliseconds compared to with indexes at 67 milliseconds, and you can clearly see in the execution plan what it did instead of basically using a sequential scan like you can see here. So what it did is, instead of doing a sequential scan, we did an index scan. And an index is basically, like I told you, a way to order your data that only Postgres knows how to go fetch it after. But it's really a good way to find your data way faster than just having a sequential scan. And indexes have many different types, which we're not going to abord in this section of this video. But I just want to lay it out that you might want to look into indexes in the future to optimize your database. And it's really important to choose a good type of index, because there are about 3 or 4 which you can choose between, that either index by hash, by value, and by different other value types, which is really important when choosing the most optimal value. And then after that, we're gonna go check with partitions. So partitions are basically, like I told you before, a way to split a big table into smaller chunks of the table. So then when you're doing a query, the PostgreSQL engine can then route your query to the specific table that is called. And this is really where you get those enormous performance gains from partitioning your table. But that most of the time that applies when you have big data, because on small tables under a gig, it's not gonna give you a significant performance score, just because of the routing and the planning time that gets higher as you add partitions. So let's see basically without indexes and with partitions, okay? So as you can see, we went from without indexes, so we don't need this one. Without indexes, without partitions, we went from 861 milliseconds to a 69 millisecond time. So basically, pretty much the same time as the index. And what you can see is basically instead of searching through 25 million rows, we're only searching through 780,000 rows. And this is basically because we don't even need to search in the big table to find where the books are in Spanish. We simply know that the table has only books in Spanish, so we don't even need to search that. And then after that, you see that we do a parallel sequential scan. Like we said, without indexes, you don't do, you need to do a sequential scan. You don't have any other choices. That's the fastest way that Postgres knows when you don't have indexes. So then after that, the big cost is where it's going to be longer. So we got 43 milliseconds that is going to take for the sequential scan. And it's going to need to basically go through every row. In terms of the 780,000 rows that's going to go one by one to search for the two values specified, and that's going to be the ISBN. Then after that, what we have is the with indexes and basically with partitions. So as you can see right now, the main thing is indexes and partitions are not always the best way to go. And this is really where I recommend you to talk to an expert about that, because it can be beneficial, but it can also be penalizable if you don't choose the good combination of both. And that's really why I wanted to do this example is, as you can see, the PostgreSQL engine prioritized the index scan instead of the partition sequential scan, which is good. We're getting about only 31 milliseconds longer in terms of query. But as you can see, we're still scanning a lot of rows, and basically the index scan is taking about 12,978 of the cost, which is pretty big. So this is really why you want to check, should I use an index, should I use a partition? This is really where it comes into the plan, and you can see it in the source planification time and everything. It explains to you that it's gonna do an index scan and then apply the index condition based on the language and the ISBN. Because remember, in the past I showed you that on books parted, the difference between the other table is that we have an index that takes into account the language, the ISBN, and the ISBN 13. So this is really the difference, because with a partition table, you need to have most of the time you need to have at least the value of basically the decision to partition. So if I'm partitioning on languages, I absolutely need to set a unique constraint to the language column. But in my case, I also needed it for the ISBN 10 and 13, so I don't have duplicate books, which is really important. So this is really why you need to think about it when you're doing your database architecture diagram, and really think, should I use an index? Should I not use an index? So in this case, you don't lose performance. So this is really where I wanted to come with, is really when you're doing database optimization, you might not encounter it as soon as you start making your first project on Supabase or something on PostgreSQL. But really keep that in mind when you're doing optimization, that you really need to think of the best strategy to find the perfect optimizations for a database. So again, that's an 11x increase, so that's pretty good in my opinion. Really look into partitions. And what I suggest you doing is basically trying indexes, right? So you could try indexes, and then you basically just use create index like that. You select the table you want to do it on, the type of index, which I can do another video on that, the column, and then you can basically test it like that with a specific select. And what you can do is use the explain analyze prefix before your query, so it's going to explain to you what it's going to do, and allow you to speed up your queries. So if you guys have any questions or want to do consulting, the link's going to be in the description. I'll see you guys in the next one, and feel free to leave a like, subscribe, and I'll see you guys in the next one. Cheers.